students, how are you all? I hope you all are very well. So we are going to start our new topic, that is highest common factor and lowest common multiple, that is HCF and LCF of mathematics. You all have heard these words before it, but we are going to just learn how to find out the HCF and LCM of the numbers and where we have to use in our day-to-day life. So we are having some these type of questions we are going to use in daily life, or some we are having just like that we have to use in the mathematical operations. So we are going to learn one by one. So listen it very carefully with full focus and concentration. So we are having our in this topic we have the common factors, common multiples, problems on HCF LCM, and highest common factor and lowest common multiple. So we are having these 5 topics which we are going to cover in this chapter. Clear? So next, now we are having a different table. If you see this table, we have different kinds of symbols, just like this red triangle, and this is star, and we are having hexagon and all this. So look at these points. If you see this green diamond, or we can say green rhombus, this is for even numbers. Red triangle is for odd numbers, and this blue hexagon is for prime numbers, and this yellow square is for composite numbers, and this purple star is for even prime numbers. Okay, you have learned about them in the previous topics. What are these kinds of numbers? And we have represent here. So first thing we are having odd numbers. So 1, you have a triangle. 3, you have a triangle. 5, you have a triangle. So this represents, these are the odd numbers. And if we talk about the 2, we have 3 symbols, just like green rhombus, star, and blue hexagon. So number 2 is our even prime number, second that is even number, and the third is prime number. So this table represents which number is what. So now move to our next topic, that is common factors. Okay, let's see the definition of common factors. The common factors, what are common factors? If we talk about a number is said to be common factor of 2 or more numbers if it is a factor of each of them number. If we talk about that we have a common factor, it divides 2 numbers, then we can say that it is a common factor of these 2 numbers. Just like we have here 16 and 24. If we talk about the common factors, we will see that 1 divide both the numbers, 2 divide both the numbers, 4 divide both the numbers, and 8 divide both the numbers. Okay, so we have common factors just of 16 and 24 are 1, 2, 4, 8. Because these 4 numbers divide exactly these 2 numbers. That's why we say that these 4 numbers are the common factors of 16 and 24. Clear? Now, in the same way, we have 3 numbers, 18, 20, 42. If we find out the common factors, or we can say the divisors of these numbers, that is 1, 2, 3, 6. So these 4 numbers can exactly divide these 3 numbers. So these 4 numbers are the common factors of these 3 major numbers. Clear? Next we are having exercise, and here we have find the common factors of. The common factors we are talking about just like 12 and 18, or we can say that. Okay, let's pick question number 5. In this we have 3 numbers, we have to find out the common factor. The first thing we have to do is we have to find out the factors of these numbers. Okay, so when we talk about the factors, the factors will be equal to that number or smaller than that number. Clear? So if we talk about 25, so 25 is divided by 1, 5, and then 25. Clear? So 1, 5, 25 are the factors of 25. If we talk about 75, we are having a factors 1, 5 and 5 3 is a 15. 15 5 is 75. Okay, we can say that 15 is also a factor. Then 25 is also a factor. And last we are having 75. So these are the factors of 75. Now we are having 125. So the factors 125 is 1, 5, then 25, and 25 5s are 125. Clear? If you see that factors 25 are these, 75 have factor these, 125 factors are these. So we have seen the common factor, that is 25 here, 25 here, and 25 here. So if we talk about the common factors, so here we are having 25 and 1. Actually 1 is the common factor of every number whichever you take. Okay. So that's why we will consider 1 and 25, or we can say that this 5 is also coming in these three numbers. So we are having common factors 1, 5 or 25. Clear? So these are the common factors of these numbers. Next we will pick question number 7 to find out the common factors. Okay, now we will find out the factors of these numbers, just like 126. If we divide by 2, we are having 63, then 321, then 3, 7, and 7, 1. I know these are the prime factors, but we will consider for finding out the factor, that is 108. Or we can say that 108 we divided by 2, that is 54. Then again divided by 2, we are having 27. Then again we are divided by 3. Then 9. Then 3, 3, 3, y. Clear? Next we are having 18. So we divide by 2, this is 9. Then 3, 3, 3, 1. Okay. So we are going to write the common factors of these numbers. So first we have to write down the factors of these numbers. So here we are having 18. The factors of 18 are 1, 2, 3, 6. How I am finding out these? I just multiplied by 3 into 2, 6. 3 3s are 9. Then 3 is 9, 6, and 3 is 9 to the 18. So these are the common factors. Sorry, only factors. Now we are having, that is 108. So the first one is we are having 1, 2, 3, then 2 2s are 4, then 3 2s are 6, 3 3s are 9, then 4 3s are 12, then 4 3s are 12, and 3 3s are 9, 2s are 18, 3 3s are 9, 9 4s are, sorry, 9 3s are 27, this is a 9, and 9 3s are 27, then 3 3s are 9, 27, 9 4s are 36. Okay, then we are having 54, and last we are having 108. Now we are having 126. So here we are having 1, 2, 3, 3 2s are 6, then 7, 3 3s are 9, 7 2s are 14, then 7 3s are 21, and 7 6 are 42, 7 9s are 63, and last we are having 126. So here we are having the factors of three numbers. So now we are going to find out the common factors of these three numbers. So that means we have to find out the common factors. Okay, so we are having, that is 1, Next we are having, this is 2, then 3, then 6, then 9, or so we are having here, we are having common factor is 18 also. So we are having 18. So here we are having 1, 2, 3, 6, 9, 80. So these are the common factors of these three numbers. Clear? I hope you have cleared your doubts according to this question. Now move to the next exercise or topic. So next topic we are having, that is highest common factor. Highest common factor is that number, if you take 2 or 3 numbers and you will find out the highest number by which you can divide these 3 numbers or 4 numbers for 10 numbers, that is the highest common factor. Okay, we are going to see the definition of highest common factor which we are having, that is highest common factor of 2 or more numbers is called the highest common factor, that is HCF. Or we can say that the greatest of the common divisors of 2 or more numbers is called the common divisor. So common divisor and the highest common factor both are the same. So we have to take care of that. So here we are having, okay, let's see the example. We are having 24 and 60 are the two numbers. We have find out the common factors of these numbers. The 1, 2, 3, 4, and that's it. Okay, so if you see, what is the common factor of these numbers, that is highest common factor. So first thing we have to do is common factors of 24 and 60 is 1, 2, 4, 6, 12. So we have the factors, then we have to choose the highest factor of these two numbers, that is 12. So this is the concept of high common factors. Okay, so next is 5.2. Second topic we are having here, find the highest common factor. Okay, here we are having two numbers in which there is no common factor is there. So we have to find out when we have two numbers in which the common factor is 1. Clear? So we have to just see the what is the highest common factor, that is 1. We have to find out the HCF, that is highest common factor, and here we are having the HCF of 12 and 36 is 12. Since 12 is a common factor and here 12 divided 36, that 12 is the highest common factor. If we have two numbers and the one is the smaller number and the smaller one is the factor of that the bigger numbers, then we can say that the smaller number is the highest common factor of that particular these two numbers. Clear? So now we are having this example, so we have some conclusions over it. So first point we are having, that is the highest common factor of 2 or more numbers cannot be greater than any one of them. I told you when we have factors, so when we have to find out the highest common factor, that will be or equals to or less than. Clear? Then the second point we are having, the highest common factor of two prime numbers is 1, because they don't have any common factor here other than 1 or itself. So we have the highest common factor of two prime numbers is 1, and the given number may or may not be prime. So may be quite possible they are prime or not. Next we are having third point, if one number is factor of the other, the smaller number is the HCF of the number. So 1 is the factor of other number which we have discussed earlier. So then the smaller number is the factor of other number, and maybe it will be the highest common factor of that other number. Okay, now we don't have any other things, but here we look to find our HCF of 2 or more numbers. We factorize the number so that each factor is a prime number. Okay, so we are going to discuss the prime factorization method to find out the highest common factors. The HCF of these numbers is the product of all the common factors. Okay, see, here we have to find out the HCF, that is highest common factor. So these two methods, that first one is the common factor method and this one is the prime factorization method. Okay, so here we are having 36, 48, 120. 36, 48, 120. So we have to find out the prime factors of 36. Then we have to find out the prime factors of 48. Then we have find out the factors of 120. So these are the prime factors. Then we will have to find out the common factors. So we have seen this like 2, 2, 3. So we have to multiply these prime factors. Then we will get our highest common factor. Clear? So next we are having our exercise, that is 5B. So here we are having some questions. Some I will solve for you, and to just only for the explanation part, just you make the clear picture of the concept and the questions. Clear? So come to our question number 1. Here we are having find the common factors and find the SCF of. Let's take one example, that is A part, 48 and 64. The first we have to find out the common factor, then we have to find out the SCF. Clear? So first we have to find out the factors of 48 and 64. Okay, let's start finding out the factors. Just like 1, 2, and then 3, then 4, then 5, 6, then we can divide it by 8 also, then 9, 10, 11, 12, then this will be 18 also. Okay, then we have 18, 24, and last we are having 48. So these are the factors of 40. Here. Next we are having 64. So we are having factors of 64s are just like 1, 2, 4, 8, then 16, then 32, and then 64. So these are the factors of 64. Now we have to find out the common factors. Okay, let's see what are the common factors of these two numbers. Okay, so we are having 1, 2. Okay, then we are having 4. Okay, then we are having 8. I think one part is missing after 12 and between 18. There is 16. This is 16, this is a 48. Clear? So we are having 16 also. Okay. So we don't have this factor 80. Here we are having 16. Okay. So we are having 16 as a factor also. So these are the factors, or we can say the common factors. Now we have to find out the SCF. Can you tell me what is the highest common factor between these two numbers? Yes, that is 16. Clear? Okay. Now move to the next part. Okay, now we have find the high SCF of the following pairs. Okay. Here we are having little difficult numbers. So first thing I'm going to do is find out the prime factors of these numbers. Just like 3, that is 63, then 3, 21, 3, 7, then 7, 1. Okay, next we are having 273, and 3, 9, 3 is a 27, 3 1 is a 3, and I think 7 1 is 7, 7 3 is a 21, and this will become 30. Okay, so we are having the prime factors of these numbers just like 189. So we are having 3 multiplied by 3 multiplied by 3 multiplied by 7. And if we talk about the 273, that is 3 multiplied by 7 into 30. Okay, now we have to find out the SCF of these two numbers. So here we are having 3 and I think 7. So we have seen two common factors and 7 threes are 21. That is your answer. So 21 is the highest common factor of these two numbers. Okay, now we are having question number 3. Find out the SCF of the following sets of numbers. You can use the same method which you like, that is common factor method or permutation method. Next, we are having question number 4. Which of the following pairs of numbers are co-primes? Okay, the co-primes are those numbers which have only one factor, that is 1. Clear? So, let's see. Now we are having question number 4. So we have to find out that these two numbers are the co-primes or... Okay. We have two numbers, just one is 51 and the second is 55. We have to find out that these two numbers have any common factor or not. If these two numbers have only one factor, that is 1, then we can say that these two numbers are the co-prime numbers. Okay, let's see. Let's find out the factors of 51. Okay. If we divide by 3, we are having with 3 and this is 7. And then 17 is a prime number. Okay, after that we are having 55. Let's divide by 5, that we are having 11, that again 11, that is 1. Clear? So here we are having 51 equals to 1 into 3 into 17. Okay, next we are having 55, 1 into 5 into 11. If we see that in these two numbers, anything is common? Yes, you can say that if we talk about the SCF, there is only 1 is the common factor. So, whenever we are having 1 as a common factor or highest common factor, then we can say that these two numbers are co-prime numbers. Now come to our question number 5. Find all the numbers lying between 30 and 40 which are co-prime to... Okay students, so we are having a range of numbers that is 30 to 40. We have to find out the co-primes of 30. That means we have to find out those numbers which don't have any common factor other than 1 with 30. Okay, so we highlight this number, that is 30, then 31. Okay, 31. These numbers don't have any common factor other than 1. 32, 33, 34, 35, 36, 35, 36, yes, and 37. Then 38, 39. Okay, only these two numbers are there which are co-primes with 30. Clear? Okay. Now move to the next part, that is question number 6. Find the greatest number which divides these four numbers. Okay, so this is the real life example when you have to find out the single number which divides two or more numbers exactly. Then we have to find out the SCF of these numbers. So same way we are going to find out the SCF of these four numbers, and we have to find out the greatest number which divides all these four numbers. Clear? So first thing, we have to find out the prime factors of these numbers, just like 2, 4 to the 8, 8 to the 16, then 2, 24, then 2, 12, 2, 6, 2, 3, 3, 1. Then we are having 72. and 2, 36, 2, 18, 2, 9, 3, 3, 3, 1. Okay, then we are having 42, 20, 2, 10, 2, 5, 5, 1. Okay, next we are having 24. This is 2, 12, 2, 6, 2, 3, 3, 1. Clear? Okay. Now we have to solve these factors just like this. 24. The factors 24 are 2 multiplied by 2 multiplied by 2 multiplied by 3. Then we are having 40. So factors of 40 are 2 multiplied by 2 multiplied by 2 multiplied by 5. Next we are having 72. The factors of 72 are just like 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3. After that we are having 96. That is, the factor of 96 are 2 multiplied by 2 multiplied by 2 multiplied by 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and the last is 3. Okay, now we have to find out the HCF of these three numbers. Okay, the first one is 2, then again 2, and I think one more time is 2, and 3. This number don't carry 3. So these three numbers, 2 multiplied by 2 multiplied by 2 is 8. As answer, this is the highest number that can divide all these numbers exactly. So we can say that this is a required number. The greatest number which divide these four numbers. Okay. So now we are going to our next part. Okay. So students, now we are having next topic, that is common multiple. If you multiply any number and multiply it and we have a product in the same way, and we have two or more three numbers, then if you multiply these three numbers of different kinds and at some point maybe or may not be, they have a common multiple. Okay, just like we have taken the example, and before that we will just discuss the definition of common multiple. A number is called the common multiple of two or more numbers if it is divisible by each one of them. And how? Listen, we have two numbers 4 and 5. So we are going to find out the multiples. In multiples you have to multiply the numbers by 1, 2, 3, 4. Just like see, we have to find out the multiples of 4. So 1 is 4, 8, 12, 16, 20, 24, 28, and so on. And if we talk about the multiples, we don't have any limits of multiples because they are unlimited in numbers. Clear? So multiple of 5s, we are 5 ones are 5, 5 2s are 10, 5 2s are 15, 5 4s are 20. If we see the multiples don't have any limits, so we have to take the lowest common multiple, which is coming in both the numbers just like 20. At some point any number we have the common multiple, so we are taking this. So if we talk about the common multiple, and that is lowest common multiple, these are the two concepts which we are going to solve further. So here we are having only common multiples, so we are having first is 20, then we are having 40, and then we are having 60, and so on. Clear? So by this method we have to find out the common multiples of the numbers. Now move to our next part. Okay, now we are having exercise, that is 5C, and here we are going to find out the first two common multiples. Okay, so we have taken a number just like this. Question number 2. We are having 8 and 12. So we have to find out the multiples of 8. So 1 is 8, 8 2s are 16, 8 3s are 24, 8 4s are 32, 8 5s are 40, 8 6s are 48, 8 7s are 56. So we have find out the some common multiples. So I have written some multiples of 8. Now we have to write the multiples of 12. That is 12 ones are 12, 12 twos are 24, 12 threes are 12 threes are 36, 12 fours are 48. Okay, we have to find out the two common multiples. I think we have found it. The first one is 24 and the second is 48. So we can say that the common multiples of 8 and 12 is 24 and 48. Clear? Okay. Okay, let's pick up one more example, just like fifth part. Here we are having three numbers 2, 3, 5. So we are going to find out the common multiples, or we can say that we have to find out the two first common multiples. So here we are having 2, 3 and 5. So let's write the multiples of 2, just like 2, 4, 6, 4 to the 8, 4, 5 to the 10. Okay, then we are having 2, 6 are 12, 2 7s are 40. Okay, let's write some multiples of 3. 3 ones are 3, 2, 3 2 are 6, then 3 3s are 9, 3 4s are 12, 3 5s are 15, 3 6 are 18. Let's write some multiples of 5, 5, then 10, 5 3s are 15, 5 4s are 20. Okay, 5 5s are 25, 5 6 are 30. If you see, we don't have any common multiple right now. So we have to write the further multiples. So here we are having 7, 8 to the 16, 8, 9 to the 18, 10 to the 20. So 20 we are having, yes. But here we are having 18, 7 to the 21. Again, we don't have any common factor. Clear? So we have to write, common multiple. So we have to write furthermore multiples, just like this is 11 to the 22, and then 12 to the 24, 13 to the 26, then we are having 13, 14 to the 28, 15 to the 30. Okay, then 7, if we talk about 8 times 8 3 are 24, 9 3 are 27, 3 10s are 30. If you see, we are having the common multiple is 30, the first common multiple. Clear? So we can say that here we are having the first common multiple is 30. So if we have to find out the next common multiple, this will be the 2 times of this number, that is 60. Clear? So you can just multiply these common multiples by another way. You can find out just like this. Okay? So come to our next part, that is lowest common multiple. So first we will look the definition, then we will solve the questions. So here we are having the smallest of the common multiples of 2 or more numbers is said to be the lowest common multiple. It is LCM. Okay, just clear it with the example, that is, consider the number 6 and 9. So here we are having multiple of 6 is 6, 12, 18, 24 and so on. And then multiple of 9 we are having 9, 18, 27, 36 and so on. So we have to find out the common multiple, that is 6 and 19. We are having the first is 18, then 36, then 54. Now, because we don't have any limit of the common multiple, so we have to find out the lowest common multiple. And the lowest common multiple here we are having, that is 18. Clear? So next, we are having the B part. find out the LCM of 12 and 18. Same way we have to find out the LCM. Then according to these three numbers, okay, fine, we don't have any different thing. Okay, so we are having some important points regarding the LCM or lowest common multiple. So the first point we are having here is the LCM of two or more numbers cannot be less than any number. In factors, we don't have more than. In multiple, we don't have any less than. The multiple will be equal to or more than that number. Next is the common multiple of two or more numbers are the multiples of the LCM. If we talk about the common multiple, that is the product of the two or more numbers. Then come to the third part. The LCM of two co-prime numbers is the product of the number. Clear? So if we talk about the LCM of two co-prime numbers, because they don't have any common factor and so they don't have any common multiple also. So that means if we have to find out the LCM of these two numbers, then we have to multiply them. Clear? Next is, okay, now come to question number 4.4, that is, if a number is a factor of a number, then their LCM is the greater of the two numbers. When there are two numbers, one is the factor of the other number, then the greater one is the LCM of these two numbers. Clear? Okay. Next, we are having some other point. Just like to find out the LCM of two or more numbers, we proceed as to find out the prime factor of the given number. Okay, by taking prime factors, then we will have to find out the LCM. Take each prime factor which occurs the maximum number of times in all the factors of the given number. So the first thing is we have to find out the prime factors. After that, the maximum number of times the factors are repeated, and we will take that maximum repetition of number as a LCM. Take all the factors which are not common in the number, then we have to find out the other part, that the remaining factors which are not common, then we will have to take them. Okay, the LCM is the product of the prime factors taken in steps 1 and 2. So after last, we have to find out the product of these numbers. Okay, let's discuss these questions with the help of examples. Okay, so here we are having our exercise 5D, and here we have to find out the LCM by different methods. Okay, let's see the question number 1 here. Write first 10 multiples of the following sets of numbers, find their least common multiple. Okay, let's find out 10 factors of 4, 6 and 8. If you see, then we have to write the first 10 multiples. Okay, here we have two numbers 6 and 8. So we are going to write first 10 multiples of 6 and 8. So the multiples of 6 is 6, 12, 18, 24, 30, 36, 42, 48, and then we are having 54 and then 60. These are the first 10 multiples of 6. After that, we are having 8. So multiples of 8 are just like 8, 16, 24, 32, 40, 48, 56, 64, 72, and then 80. Clear? So now we have to find out the lowest common multiple of these two numbers, that is LCM. Clear? So have you seen any common multiple? Okay, I have seen, I think, 24. Here 24 is the lowest common multiple of these two numbers, and this is also the LCM. So we can see that LCM of 6 and 8 is 24. Okay. Now, I hope you all get this point. After that, question number 1, we will go to question number 2. And here we are having find LCM of the following sets of numbers by prime factorization method. So here we are having some numbers. So this time we are going to take three numbers to find out the prime factor, to find out the LCM by prime factorization method. So I have taken F part here. Okay, we are having 18, 24, 36. Okay, so let's find out the factors of 18. We have divided by 2, just like 9. This is 3, 3 bar. Then we are having 24. This is 3, 8, 2, 2, and 1. After that, we are having 36. Okay. So here we are having 36. Let's find out the factors just like 2. This is 18. Then 2, 9, 3, and 3. Okay. So here we are having prime factors of 36. That is 2. Multiply by 2, multiply by 3, multiply by 3. Here we are having factors of 24, just like 3. Multiply by 2, multiply by 2, multiply by 2. Here we are having factors of 18, just like 2 multiply by 3, multiply by 3. The first thing we have to do is we have to find out the LCM, that is lowest common multiple. And how we are going to do this? First thing, we have to write the common factors. Just like you have seen 2. Okay, then we are having 3 as a common. The first we have to write these two common factors, just like 2 multiplied by 3. I don't think so that we don't have any other common factor. So here we are having 3 2s are 6. Okay. Then we are having here is this 2 यहाँ पर आ गया है and ये 3 यहाँ पर आ गया है. Okay. And last we are having 2. So we are having LCM is 3, 3 is 9 and 8, and this will become 72. So here we are having the LCM is 72. Now we are having question number 3. Find the LCM of the following sets of numbers by short division method. Okay. Let's pick up one question here, just like E part. We are going to find out the LCM by short division method. So we have to just write the numbers just like 45, 75, and 125. Okay. Now you have to divide these three numbers by a common number. Just like I am going to divide it by 5. 5 9s are 45. 15 5s are 75. 25 5s are 125. Again, I am going to divide by 5. But this is not divisible by 5. So I leave it as it is. Just like this 9. If I divide 15 by 5. So we are having 3. Again, I divided 25 by 5, we are having 5. So now we are going to divide by 3. That says 3 3s are 9, 3 1s are 3, and this is 5. So we are having these factors. So I'm going to find out the LCM by short division method. When we use this method, we have to just only multiply these factors. Just like 5 multiplied by 5 multiplied by 3, and these two factors also 3 multiplied by 5. Okay, this is 5 525, 5 are 125 multiplied by 9. So this will become 9 5 are 45. This is 4, 9 2 are 18, 19, 20, 21, 22. Again 2 carry, 9 1s are 9, 10, 11. So this will become 1125. 5. Okay, so this is the least common multiple of these three numbers. Okay, next is question number 4. That okay, we are having one more property here. Verify that the product of LCM and SF is equals to the product of their numbers. Okay, the first thing we are going to do is we will take one number, that is 24 and 60. The first thing we have to find out the LCM and SF. Okay, so if we going to talk about property, that will become, that is product of LCM and SCS equals to product of two numbers. Clear? Okay, now we are having 24 and 60. Okay, let's find out the LCM. Okay, 24 and 60, we are going to find out the prime factors. Okay, now we are having 24. This is 2, and this is 12. 2 is 6, 2 is 3, 3 is 1. Here we are having like 2, that is 30. 2 is 15. 3 is 5, and 5 is 1. Clear? So now we are going to find out the LCM. Okay, now we are going to find out the LCM of these two numbers. Okay, we are having 24. The factor of 24 is 2 multiplied by 2 multiplied by 2 into 3. And next is 60, that is 2 multiplied by 2 multiplied by 3 into 5. Okay, that is LCM. If we talk about the LCM, so we have to take first these two common factors and this one. This is 2 multiplied by 2 multiplied by 3 into 2 into 5. 2 to the 4 to the 8, 5 is 40, 4 3 is 12. And this is 120. Okay, now we have to find out the LCM. Sorry, SCF. So we have to find out the highest common factor. So I think we are having 3 and these two. This is 2 multiplied by 2 multiplied by 3. So 2 to the 4, 4 3 is 12. So 12 is our highest common factor. Clear? Now we are having LCM is 120, SCF is 12. So we are going to use in this formula the product of LCM and SCF is equals to the product of two numbers. So LCM we are having, that is 120, SCF we are having 12. Here we are having two numbers just like 24 and 60. So let's multiply. 12 12s are 144 and 0. Okay, now we are going to multiply these two numbers, that is 0, 6 4s are 24, this is 2, 6 2 are 12, 13, 14. Okay, so we are having the equal answer. So this is the property. If we have the LCM and HCF of the two numbers, that is the product of these LCM and HCF equals to the product of the two numbers. So this is a property which we are going to use in our questions. So we have proved that. So we are going to our next question. Okay, now we are having 5, 6, 7. Okay, the question number 5, we are having the SCF of two numbers is this and LCM is this. One of the number is this. Okay, let's pick this question number 5. We have given the same statement which we used earlier in the question. Okay, so here we are having, again we are going to use that formula, that is SCF into LCM equals to product of two numbers. Clear? So here we are having SCF is 45 Now we are having LCM, that is 270. After that, we are having the formula of product of two numbers. The one number is we are having 135, and the second number we are having 8. So we are going to solve this part, that is 45 into 270 divided by 135 equals to 8. So 135 2s are 270 and 45 into 2, this will become 90. So 90 equals to 8. This is our second number. Clear? So we are going to use this formula in this way also, according to our requirement of the question. Here we are having, okay, these are the same type of questions which you have to solve these parts. Okay, now we are having some word problems type questions related to HCF and LCM. Okay, the first thing, we are having example 1. Here are the two rows. Find the maximum length of rod that can measure then exactly. When we have to find out the maximum number, so we have to find out the SCF for that, and this problem can be used in other parts also, just like racing and other things. Next example we are having, if three clocks rings at the interval of 15, 20 and 25, and at what, and they ring, if they ring at 3 o'clock, at what time will they ring together again? In this case, we are going to find out LCM, when they are going to meet, and just these kind of questions. Clear? When three racers are running in a lab, and these three racers have the different speeds also, but at same or some point they will be coincide at that point. It clear? So at what time will they coincide, or at what speed they will have to run? So these kinds of question, then we have to use the LCM. Clear? So okay students, now we are having our exercise, that is 5E, and we are going to solve these questions which are related to our SCF part. So we will take our first question, that is find the greatest number which divides 53 and 77, leaving the remainder 5 in each case. So first thing, we have to find out the required number from these two numbers. Just like the first number we are having, that is 53, and we want a remainder 5, so we have to subtract 5 from this number. So we are having the first number is, that is 48. Clear? Next we are having 77. Again we have to find a remainder 5 from this number. So after subtracting 5 from 77, we have 72. So we have two numbers, 48 and 72. Now we have to find out the SCF of 48 and 72. Okay, now we are having 48. So divided by 2, that is 24. This is 2, 12. This 2 is 6. 2 is 3. And 3 is 1. And second number we are having 72. So we divided by 2, that is 36. Divided by 2 is 9. This is 3. 3, 1. So we are having the factors, prime factors of these two numbers. So the first one is 48, and the factors 48 are 2, 2, 2, 2 and 3. And next we are having 72, and the factors are 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3. Clear? Now the SF of these two numbers is, we have to find out the common factor 1, 2, 3 and this 3. So we are having 2 multiplied by 2 multiplied by 2 into 3. That is 8 3s are 24. Okay. Now the 24 is the required number which divides these two numbers, 53 and 72, and leaves a remainder 5 in each case. Okay, let's divide 24 and 53. Okay, so 53 and this is 24, 24 to the 48 and we are having 5 as a remainder. Okay, so we proved a thing that we have a greatest number, that is 24, if we divide these two numbers and leaves the remainder 5 in each case. Clear? So now move to the next part, that is question number 3. There are two footpaths in a park 160 meter and 44 meter long, and find the maximum length of the rope that can be measured then exactly. Clear? So we are having third part. Okay, there are two footpaths in the park just like 160 meter and 224 meter long. So these are the two footpaths and we have to find out the maximum length of the rope. When we have to find out the maximum length, then again we have to find out the SCS. So we have to find out the maximum length of the rope that can measure them exactly. Okay. So the length of the park is 160 and 224. Okay. This is 224. If we divide by these two, okay, this is 80. Then again we will divide by 2. This is 40. Then 2. This is 20. Then 2. 10. Then 2. 5. Then again 5. 1. If we divide by this 2, the 1, 1, 2. Then 56. Then 28. Then 14. Then 7. Then 1. Okay. So we are having 224 and 160. The factors 224 is 2. How many times? 1, 2, 3, 4, 5 times 2 is there. Just like this. 2, 3, 4, 5 and last we are having 7. And next we are having 160. The factor of 60 is 1, 2, 3, 4, 5. Okay, 2, 5 times is there. 3, 4 and 5 and last is 5. Okay, now we have to find out the HCF. So HCF is 5 times 2 is 2 to the 4 to the 8 to the 16 to the 32. So we have to take a rope of 32 meter in length, which can measure these two fields of length 160 meter and 224 meter long. Okay, so now I hope this is clear. Now move to our next question. Okay, we have done this part. Okay, now we are having more questions just like this. Okay. Now take question number 7. Okay. Here we are in question number 7. Determine the smallest number which when divided by 24, that is 40. Least remainder in 5. Okay. So here we have to find out the smallest number and which is divided by these three numbers and leave a remainder 5 in case each case. The first thing we have to find out the LCM by these three numbers and then we have to add 5 to find out the required number. Clear? So first I'm going to find out the LCM of 24, 36 and 40 and this will become 24, 36 and 40. So we are going to find out the LCM. Just like 2, this is 12. Here we are having 18 and here we are having 20. Again 2, this is 6, this is 9 and this is 10. Here we are again 2, this is 3, this is 3, 3 is 9. Sorry, this is not divisible, this is 5. Again we are having 5, this is 3, 9 and 1, then 3 and 3. So LCM of these numbers are just like 2 multiplied by 2 multiplied by 2, then 5 multiplied by 3 multiplied by 3. Okay, so this is on 9, 9 to the 18 to the 36. This is 360. Now we have to find out the required number. So here we are having required number. So this is the smallest number which is divided by these three numbers, and we want remainder as a 5 as a remainder. Okay, so required number will be is 360 plus 5. This is 365 is a required number. Okay, so I hope this topic is also clear. Okay, students, I hope I am capable of clearing all your doubts and making this concept just of LCM and SCF is useful for you all. So thank you for listening us carefully.